Good morning and welcome to Project Maleth Rocket Launch webinar. Project Maleth being the first Maltese scientific program to go into space. We are here today at the Valletta Campus Theatre, and with me are the main stakeholders of this project. I'd like to introduce our panel. We have Professor Joseph Borg, who is the project leader and molecular geneticist. We have Mr. Gordon Grech, who's the co-founder and executive director of Arkafort. We have Mr. Chris Busuttil, who is the managing director of Evolve Limited. And we also have Christine Gatt, who is the PhD student who actually did this started this scientific program we will be talking about. We will also have some collaborators, guest speakers with us online. They're very interesting people. So I would like to ask you to stay with us throughout this 1.5 hours, because also what will be happening in about an hour, approximately an hour, we will be witnessing live the actual launch of the SpaceX vehicle, which will be departing Cape Canaveral, Florida, and is destined to space. So this is the International Space Station, of course. So this is a very exciting moment as well for us Maltese to actually have the first scientific project going into space. I would like to start with you, Professor Borg. Obviously, a year of preparation leading to this very day. What will happen next?
Yes. So, good morning, everyone. Thank you, Claire, for your kind introduction. Yes, indeed. So after just under a year of preparation and a huge effort from many different stakeholders, some of which you see here today, others who are working still behind the scenes in the labs and also abroad. Today is the actual launch or delivery of our experiment to the International Space Station. Of course, myself and a couple of my colleagues who worked on this project, who are biomedical scientists, we view the International Space Station as an extension of our laboratories. So the International Space Station, it is what it is. It is a huge orbiting or an outer space space station. However, it is also a laboratory which conducts, amongst many other things, biomedical science, biology, chemistry, and a number of specific experiments that we always wanted to plan or envisage. Actually, now we could actually conduct these set of experiments in outer space in the context of microgravity.
Just very briefly, but it's also important for the people to understand. There is this BioCube. Explain to us what is actually going to be going to space. There's a BioCube with the experiments. And once this BioCube arrives, the experiments will then remain there for how many days, and what is the effect that you are looking forward to then receiving when they come back?
So the BioCube was designed and developed in collaboration with a company based in Brussels, in Belgium, Space Applications Services. We will hear about them today later on. And this BioCube, as you rightly said, it houses biological samples. These are skin samples that come from diabetic foot ulcers. And together with these skin samples, there is, of course, inevitably the bacteria. And collectively, we call it a microbiome, which is a group of different bacteria which are occupying or residing on that skin section. Now, the idea is that these bacteria, some of which are resistant to treatment, are very hard to treat, and usually, unfortunately, it might lead to amputations for these patients who are suffering with this condition. So the idea is that if these bacteria are so resistant, so adaptive to stress, what happens to them at a molecular level, at a genetic level, at a biological level? What happens to them when they are also exposed to the harsh environment of space, microgravity or increased radiation? So we want to see what happens in space and in our labs on Earth, and basically the data that we get back or we tease out can help significantly to tease out those interesting biomarkers, we call them, or targets that we might be able to target. And in so doing, you can treat more efficiently or more precise.
Thank you very much. Actually, you explained it really well so that we could all understand the importance as well of such a scientific project. In fact, before I move on to the other guests, I think I need to ask you this question. How did it all start, and also how difficult or easy was it to engage other people in Project Maleth?
Okay, so Project Maleth, as I said in the beginning, so initially it was an idea concept developed by myself and my close collaborators. The original funder is the Ministry of Foreign and European Affairs in Malta. And then we also saw the collaboration with the academia at university. So you have the government, the university, and now, as you see today, also the private sector, where we have two companies, Evolve and Arkafort. These were facilitated by the RIDT, this is the Research Innovation Development Trust at the University of Malta, managed by Wilfred Kennelly. Here I thank him for bringing me such important private collaborators. And also, so together, collectively, this tripartite venture or group sort of brought together all the necessary ingredients, if you may say, to bring this project to fruition. I would dare say that with just one of the entities alone, academia alone, or government alone, or industry alone, probably it might not have achieved or arrived at this stage as you see today.
I understand. Thank you. Thank you very much. I move on to you, Mr. Gordon Grech. Obviously, as Arkafort, you have a very important role. Even today, I was seeing you very busy getting everything all organized. Later on, we'll be also seeing your control room, where all this can be seen even by the public. Yeah. But my first question is going to be about your collaboration. What is significant about that to Arkafort?
Sure.
And also what's going to be happening now?
Sure. Yeah, so first of all, thank you for the introduction, and thank you, Professor Borg, for the opportunity to be participating in this project. For the past year or so, we've been looking at science projects or a science initiative in which we could actively contribute and participate. And I remember having this meeting with our IDT, with Wilfred actually, and as soon as he mentioned the opportunity for us to collaborate in this project and to collaborate on Malta's first space mission, we immediately had to say yes, obviously. And after giving the idea some thought, and after even doing some brainstorming with Professor Borg and his team, we came up with this idea of setting up a mission control station, where basically we'll be monitoring the cube, we'll be connecting with the cube, actually establishing this network connection between Malta and the International Space Station. And from there, we'll be able to look at images about the experiment, we'll be able to take videos of the experiment, we'll be able to get some telemetry of the experiment, how things are going, acceleration, this and that, and we'll show you a bit more about that later on as well. And all of this data is going to end up in our data center, basically, where then it's going to be analyzed and processed and made available to Christine and her team at the University of Malta. So that's the idea about our involvement. It's obviously a privilege to be working in this experiment. It's a first on so many levels for our nation. But we also believe that it's a door opener for Malta to enter into this new space economy business, right? So it can be something that it can be the start of something really, really big, actually. We as a company, we're committed to keep on investing in the development of new technology, and we're always on the lookout for new ventures, new technologies, new sustainable entrepreneurial avenues, so to say.
Interesting.
And obviously, Project Maleth is definitely a perfect fit for this.
Thank you. Thank you very much. Another important person, and also someone who, as a company and as himself, believed immediately, almost, in Project Maleth. Mr. Chris Busuttil, he's the managing director of Evolve Limited. What first convinced you about it, and also how did you respond, and what's your contribution?
Yes. I am tempted to say, you know, our generosity and big heart, but our Joseph smile, maybe. But really and truly, I mean, as Gordon just said, there will never be another first. So this is the one and only first.
True.
I mean, will for sure, and we've already started working on new ideas, but for sure there will be others, but there will never be another first. So to be associated and to support Professor Borg and Christine and the whole team in such an endeavor is an honor and a privilege. Where do we come from? As Evolve, we facilitate scientists, biomedical scientists, engineers, to actually make science happen. So this is what we do every day. In fact, our mission, it's on our website, it's on all our socials, is that together we can improve the impact that science and technology have on society now and in the future. So this is a perfect fit. So I would dare say that alignment is the key word, why we responded so quickly, because all the right buttons were pressed immediately. This is what we do every day. This is what makes us wake up in the morning, the difference we can make. And together with the scientists in the field, in the lab, and in space, new frontiers. Yes, we're also obviously very proud to be here and very grateful. This is not the first collaboration we had with Dr. Borg, Professor Borg. I'm going to call him everything today, Joseph, Professor, Doctor. To me, he's a friend, so that's the most important.
I think today also, by hearing you speak, this is something that I'm saying there's a lot of inspiration as well, and we can inspire the younger generation to take up such project, invent such project, and approach people like you to support them.
Absolutely.
Thank you. Thank you very much. It's time now for me to start making some connections with our collaborators who are online from abroad. We first have Dr. Hilde Stenuit. Are you with us, Dr. Stenuit?
I think I am. Good morning to Malta.
Good morning to you. How are you? You are in the Netherlands, am I right?
That's correct.
Correct.
Yes, in Netherlands.
Thank you. Dr. Stenuit, I'm going to ask you about, obviously, the space application services, because this is what houses the Project Maleth, and I would like now, obviously, to hear firsthand from you a little bit about it, how it works.
Okay, and to do so, I would like maybe to share my screen, and maybe you can confirm if you see that correctly.
Yes, correct. I saw it, yes. That's it, we can see your screen.
Excellent. So thank you, first of all, to the organizers there of Arkafort, and also to Professor Borg and all of the colleagues there for having me here to pass our joint excitement for this event. And so on your question, how this all started with Ice Cubes, maybe first. So this Ice Cubes platform has been brought to space in 2018. And we started this initiative of the Ice Cube service by our company, Space Application Services, as Joseph mentioned, with headquarters in Belgium. And we set it up through a partnership with the European Space Agency. And so the team behind Ice Cubes is a highly enthusiastic and experienced set of people that most of us actually supported the European Space Agency before. And we saw there was a need and a wish to be able to access space for research and for technology, for education, and also for inspiration, as you just mentioned, at people's own initiative. And when people think of going to space, they of course think of space exploration, maybe space colonization, but there's also very interesting research that can be done where space and the assets of the space environment are actually being used for us Earthlings. In fact, when you look to the potential to benefit from these unique assets of the space environment, there's an awful lot of sectors of applied research and development that can actually benefit from going to space. And today we're talking about a very interesting biotech or life science R&D related project. And that is actually very great that these two sectors between the space sector and the biotech sector can actually engage to bring these very fruitful and beneficial collaborations. So on our service, on our platform, on the right, you see a picture of the platform that is based in the European module of the space station. And so today, the launch will bring the BioCube for the team of Professor Borg to the space station, and then later it will be installed in the IceCubes facility. And we bring this type of modular units or cubes regularly. They can be connected in the facility. They get power, they get data, and they get this real-time connection that Gordon was also referring to. So they can see real-time the images or real-time the data. And so we do that for research projects, for technology projects, for educational, inspirational projects. And so we bring them on board, as you see on the picture here. Today we are here obviously around Project Maleth, and we are so excited to have met Professor Joseph Borg and be able to serve this really exciting research launching to the space station today. And a collaboration, and I really want to say this, with an inspirational and a highly driven and so enthusiastic researcher as Joseph is really an honor and a pleasure for us to serve his science. So the launch will bring his science cube or BioCube with the human skin microbiome samples to the ISS, to the facility. It will be operated there for the next couple of weeks, and then there will be a lot of work of analysis on the samples when they return to the Earth in a couple of weeks. And from there will be the future. So we at IceCubes are super excited to see this first launch for Malta, for the team of Professor Borg. But as was mentioned, in the space sector, these are crucial times where there's so much changing. Access has never been easier. New space stations are being built, and our colleague Anjali will talk about that. There's space economies, space investments that are boosting, and private initiatives can innovate, can discover. And so we're truly excited where non-space and space sectors can engage, and where we can find these really beautiful ways to collaborate and leverage these collaborations to the maximum. Project Maleth of Professor Borg is a first in so many ways, and we are certain it will lead to interesting results as part of this first ever Malta space mission. But we also look very much forward to the future and the vision of this strong collaboration, and where it will jointly bring us with all of these entities that are now already engaged. So thank you so much, and back over to you, Malta.
Thank you. Thank you very much, Dr. Stenuit, also for your energy and passion and, in a way, encouragement as well. I think this is a moment where I feel her and other collaborators, which we will be speaking to, give us the energy to, like I said before, create more missions. This is the first process. Thank you very much. I move on now to hear a recorded message this time, but it's from an important collaborator. We will listen to one of the research collaborators and principal investigator who is based at the NASA Ames Research Center. And let's see what he has to say about Project Maleth. This is Professor Afshin Beheshti.
Hi, my name is Afshin Beheshti. I'm currently a principal investigator and bioinformatician at KBR at NASA Ames Research Center. Also, I'm a visiting researcher at the Broad Institute and the president of COVID-19 International Research Team. Currently, I've been having a very fruitful collaboration with Dr. Joseph Borg for over the past year. And some of the projects have involved working on space biology and how we can further look at the biology involved changing when you're in the space environment. So one specific project that we have been working on is looking at how blood changes, or the factors in the blood changes, globin specifically. And to that, we have been working with the platform that NASA has called GeneLab. And GeneLab is where all the space-related bioinformatics or big data ends up. So we've been mining that data, looking at previously publicly available data from previous experiments done that were from samples flown to space. And we've been coming up with some interesting interesting story for that to be eventually published, hopefully published soon. And Dr. Joseph Borg has been a great pleasure to work with, and I've been honored when he asked me if I wanted to collaborate with Project Maleth. And with Project Maleth, as you all know, there's a lot of interesting different aspects of it related with diabetes and the human skin and the microbiome interaction when these samples will be flown to space today. One aspect that I'm specifically going to be looking at is on microRNAs. And microRNAs are small RNAs that are involved with either good things or bad things in your body and can regulate hundreds and hundreds of genes. And to this aspect, I've previously been able to identify a microRNA signature associated with spaceflight response. So when samples like mice or other samples like these things have been flown to space, I've been able to identify a microRNA signature that is being dysregulated in space, which would cause downstream impact on health and disease and other related issues that you don't want astronauts when they're, let's say, traveling to Mars or the moon or staying in the International Space Station to experience. So in this aspect, I'm going to be applying the same type of ideas and looking at how these microRNAs are behaving and changing in the samples that Dr. Joseph Borg is sending. So I'm going to be really excited to see how these changes happen in the skin and how they're related to diabetes that are changing and the diabetic changes that might be instigated by the space environment, and how we can potentially use these microRNAs as another way of a biomarker for health issues, or even targeting them as a potential countermeasure or therapeutic to be able to combat the effects of spaceflight to make it much safer for astronauts to travel. So again, this is an exciting opportunity that I'm involved with Dr. Joseph Borg, that he's got me involved with. I'm collaborating. I'm looking for many years of fruitful collaboration with him, and I'm very excited to see the outcome of today's experiments being flown to space and then coming back. And the more exciting part happens when we actually get our hands on the sample. And then we could actually look at the neat biology and the exciting biology that is changing over time that is spent on the International Space Station. And I look forward to the collaboration with Dr. Joseph Borg and Dr. Chris Mason that we'll be doing in the next year or so, and probably more collaborations to come, hopefully, to send samples to space. So I thank you for this opportunity to speak to you, and I also thank Dr. Joseph Borg for the opportunity to collaborate with him on this exciting project.
Thank you very much, Professor Beheshti. I must ask you a very quick question before we move on to Professor Mason. How did you manage to communicate and find these people and convince them?
Okay, I think partly to blame would be the pandemic or the COVID-19 situation itself, because it sort of restricts you in a way on the type of work that you do or the mindset that it has to change. However, more practically, my passion and my main area is blood research, specifically thalassemia research. From here, I say hello to Professor Alex Felice. And on blood research, on seeing specific research articles published in the context of space and the blood physiology in space, it led me to Afshin and another colleague, Chris Mason. They worked a lot on blood research of astronauts. And the questions I asked to them in order for me to analyze or detect certain important changes, they had not looked at them themselves at a hemoglobin level. And they said, listen, we can think of ways how to collaborate on this topic, and of course any other thing that comes along. And Project Maleth is, of course, another thing on top of the blood research that I'm doing.
Fantastic. I would like to say good morning and welcome the Honourable Minister of Foreign and European Affairs, Evarist Bartolo. He just joined us. However, we will be hearing what you have to say as well about the Project Maleth and the involvement of the Ministry very shortly. I think it's interesting to continue hearing all the collaborators in order for us all to get a bigger picture of what is actually happening today and why this launch is so important. So as you mentioned, and as Professor Afshin Beheshti mentioned, Christopher Mason, he's also a seasoned principal investigator who has led and co-led a number of successful missions for NASA genetic studies, has also collaborated and is collaborating with Professor Borg. And he's going to be meeting us, I believe. Christopher Mason, he's also a oh no, no, it's a recorded message. Okay, so we have a recorded message from Professor Mason to share with you.
Hello, I'm Chris Mason, Professor of Genetics, Physiology, and Biophysics at Weill Cornell Medicine. And it's my pleasure and honor to give a bit of a shout out and support for the mission being led by Dr. Joseph Borg and the University of Malta to get some science up into space. And it's something that we've done a fair amount in my lab at Cornell. And I'm actually calling you all now on vacation, and my family is in the other room. But I really want to take just a few minutes to hop online and say that it's a very exciting mission, that we can actually start to think about diabetes and the microbiome and sort of human cells and how those all interact. And we know from our previous missions and work that we've done that the human cells change, human physiology changes, the microbiome changes, the collection of all the cells that are not just human, but that comprise a significant part of our biology and our biochemistry and our physiology. All these things change when you're in space. We've led at this point now 8 different missions with NASA and other space agencies that have looked at what happens when you send identical twins into space, or other astronauts, private astronauts. We've taken analog missions, and we've even gotten sequencing working in space. So I've been really honored to work with NASA and many collaborators over the past decade, getting really genomics to bear for current missions and planning even for things that would work on the moon or even Mars, and how we could actually bring personalized medicine into space, to bring diagnostics into these far-reaching places where missions are coming in the next few years. So I am really also excited to start to collaborate with Dr. Borg on this mission. We'll be working a lot on the transcriptome and microbiome analysis, and that is, what happens to the cells, how do they communicate with each other, both human and microbial, and we'll be working to characterize those samples as soon as they come back to Earth. And it's also been really fun planning this mission with Dr. Borg and the entire research team. And again, I wanted to be brief because I'm on vacation, actually been doing a lot of coral restoration and scuba diving, so trying to clone out species here and get the coral to be restored. I even have a matching t-shirt, but it's a vacation shirt. So again, wish I could be there in person. Looking forward to hanging out with Dr. Borg and the whole team at some point when COVID ends, and really congratulations on the mission. I hope the launch goes well, and look forward to getting the samples back to Earth so we can jump in, begin to characterize them, and start to understand biology as it changes in space, and even start to plan for biology as it gets towards the moon and Mars, and someday even farther. So really looking forward to it, and good luck and congrats.
Professor Mason, he just made the scientist look really cool and relaxed, and telling us obviously this is part of what scientists do as well, be basically on the job and doing projects that are related to different areas. That's very interesting, and thank you, Professor Mason. We now have Dr. Anjali Gupta. This is a very interesting thing to hear from you, Dr. Gupta. You are from Axiom Space, the world's first commercial space station, and the world's first taking a full private citizen astronaut crew to the International Space Station. I've been teased by Professor Borg that I should be one of those citizens, Dr. Gupta. Can you hear us? The world's first commercial space station. We may be a bit on delay. Hello, Dr. Gupta. Crew to the International Space Station. Good morning. I'm teased by Professor Borg that I should be. Can you hear us?
Yes, I can hear you.
Can you hear us?
Good morning.
Thank you. We just have a little bit of a technical delay here in studio, so excuse us if you are hearing double, because that's what we're hearing. But it seems good now. Can I ask you the question? I think we have a good connection now.
Yes, good morning, good afternoon, and good evening. What an honor to be here. Thank you to Dr. Borg for extending this invitation. Yes, I'd like to introduce you to Axiom Space and Axiom Station. My name is Anjali Gupta. I am with Axiom Space. I just want to begin with a little history of space stations, which have been around for over 50 years. And in these 50 years, we have learned quite a bit about the space environment, the effects of space and microgravity on living organisms, and how to live in space. The ISS itself has been orbiting Earth for over 20 years and has provided incredible insights. And it's been such a source of inspiration for people around the world. However, the ISS is coming to an end, and to ensure humanity's presence in low Earth orbit, Axiom Space is a follow-on space station to the ISS. Axiom Space is building the world's first commercial space station. Our vision is to build a thriving home that benefits every human everywhere, and our mission is to improve life on Earth and foster those possibilities beyond it. And to give you a little bit of a perspective on how Axiom Station will be assembled, I'd like to share my screen and share this video with you, if you don't mind, very quickly. So here is, I hope you can see my screen.
Yes, we can.
Okay, great. Let me just hit play. So this is a modular design of Axiom Station. And what you'll see here is this robotic arm that is repositioning an element. So these modules will be flying up on a rocket and launched, and then they'll be released and they'll be free flying to the existing International Space Station. And each one of these modules is has its own navigation and control system, and they'll be assembled on orbit. This, what you see here, is the power thermal module. It's now expanding, and the solar arrays are being deployed, and now it's becoming a free flyer. So this just gives you a really brief, quick perspective on what to expect with respect to space station assembly.
Incredible.
Here, what's also happening at Axiom Space is that we're already starting to build our space station. Earlier, you saw me in the Earth Observatory. These windows will be the largest windows to the Earth. They're under construction. We're doing some pressure testing. In the picture on the right, you see the windows being rinsed off and being prepared for a chemical coating. Here, this is another element of the space station that's being manufactured. This is going to be part of the port entry. And, you know, with this video and these photos, I've just provided you with a tiny glimpse of what the future holds. Just want to reiterate that today is a historic day for the people of Malta. It's a tiny nation, but with very big, big dreams. I wanted to share a quote with you from the late Dr. Carl Sagan, and this is one of my favorite quotes from his book, Cosmos, and I'd like to read it to you. It goes like this: "Exploration is in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars." Dr. Joseph Borg is a true explorer, and now his research is setting sail for the stars. I hope you are inspired by Dr. Joseph Borg's research as much as I am, and we at Axiom want to help you with your big dreams. And we're supporting him, and we're so excited for Dr. Borg and for all of Malta and the Maltese people, the inspiration that he's providing for not only this generation, but for future generations to come.
Thank you very much, Dr. Gupta. Thank you. I was in fact going to ask you, like, what would you foresee in terms of the relationship between Axiom Space and projects like the one that you are here working with, of Professor Borg? I think you summed up your speech quite nicely, but if you would like to contribute to your involvement in relationship with other projects.
Absolutely. So with the space station coming online, with Axiom Space Station coming online in 2024, this provides a new way of doing research in space. We are the leader in sending private citizens to space, to the International Space Station currently, and then in the future to Axiom Space. Now imagine if Dr. Borg could travel with his ice cubes, with his experiments, to the International Space Station. And he will be able to do that, in collaboration with Axiom, and then ultimately to Axiom Space, to the space station. We believe that this is a first stepping stone. Research is such an important part of what the future holds. We hope to build cities in space. And to be able to do that, we need to understand the fundamental changes that occur, beginning with these extreme environments. His research is so important in understanding how biology changes in space, and then how can we apply that to improving humanity back on Earth, and also helping move forward in space.
Thank you very much, Dr. Gupta. Thank you. She's sending you. She's not sending me, okay? But I'll still take the invitation.
I have to make a fair amount of convincing first.
Thank you very much. We continue our transmission here before time runs and the SpaceX launch is ready to go. So we have another pre-recorded message which we would like to share with you, a person who is also very important, a collaborator, Dr. Jeffrey Pulicino Orlando. He's the executive chair of MCAST. Today, on today's occasion of SpaceX launch to the ISS, he sent us this message.
Honorable Minister Bartolo, Professor Borg, Project Maleth, collaborators in Malta and abroad, distinguished guests. Good morning. I am honored to be addressing this event, which is marking the launch of Project Maleth. This project is notable since it leverages on different facets of science within a multidisciplinary, cross-sectorial and international setting. The Malta Council for Science and Technology is well known for the largest project it has delivered to date, Esplora, the National Interactive Science Centre. Esplora has indeed been supportive in the run-up to this launch event by raising awareness amongst the public with regard to this notable initiative. In fact, Esplora, as a national vehicle for science communication, welcomed the news of Project Maleth and readily promoted the project. Project Maleth will look at the adaptation of bacteria, collectively known as a microbiome, to spaceflight and space conditions such as microgravity and increased radiation. Learning how these bacteria react and adapt will help us understand better how they can be combated in a more efficient manner. Demonstrating how science is relevant to the environments which we submerge ourselves in as we go about our daily lives is important. It's important as we often take science for granted and do not always appreciate the importance of STEM subjects and careers in overcoming daily societal challenges. Bridging the gap between science and the public is vital. The Malta Council for Science and Technology is also known for its technical remit, which is focused on research and innovation together with space, with respect to policy, strategy, funding programs, and internationalization. We have a small but efficient team that, together with the support of the Ministry for Equality, Research and Innovation, is more than ever before managing and promoting increased research program opportunities and funds. Thus, the Malta Council for Science and Technology is a key organization within Malta's research ecosystem, and it will become ever more so in the years to come. We are also responsible for space policy, a number of space-related programs and initiatives, as well as being the national contact organization for Malta's relations with the European Space Agency, ESA. We, in fact, work very closely with the European Space Agency on a number of collaborative initiatives, such as the implementation of the Space Research Fund and the Space Education Programme. Moreover, and in order to support Project Maleth, MCST has assisted the consortium through ESA's interest in providing a broad communication coverage for the project, as well as the engagement of astronaut Thomas Pesquet in project dissemination from the International Space Station. I am convinced that this will be the first of other collaborative science experiments and missions of this kind. Thus, whilst conveying my sincere and best wishes to Professor Borg and his colleagues for a successful project, I look forward to not only hearing about the results, but also about the future ambitions of the team. Thank you.
Thank you very much, Dr. Policino Orlando, Executive Chair of MCST. I would now like to extend the floor to our Honourable Minister for Foreign and European Affairs. Of course, today is a very important day for Malta, and I would like you, as Minister of Foreign and European Affairs, to tell us what this occasion brings to Malta.
Well, first of all, I have to blame Joseph for walking into my office with his disarming smile to tell me, don't think I'm crazy, but I'm going to suggest something. And it's a privilege to be a minister and have someone like Joseph walk into your office to tell you that he has come with an exciting initiative. And I wanted to support it straight away. I think he knocked on an open door because he knows that we worked together before. As Minister of Education, I got government support to join the European Molecular Biology Organization. I didn't know anything about it. It was thanks to his efforts to educate me in these areas that I could appreciate how important it is. But I really believe in this project, for a very simple reason. I can tell you it's very depressing to be a Foreign Affairs Minister in today's world, because I think we have a lot of mistaken priorities. The world has enough knowledge, has enough money, has enough science, has enough technology, has enough resources to solve, or at least address much better, the huge problems that we still have, whether it's pandemics, whether it's poverty, whether it's illiteracy, whether it's starvation. But we keep on getting it wrong. So when you have, even though it's a very modest, small project like this, it's a breath of fresh air. I mean, I just have to say, last year, during the pandemic, 9 countries spent more than $72 billion to modernize their nuclear arsenal, which they say they're not going to use because that would destroy the world. But we managed to find $72 billion on that. We haven't found $50 billion for vaccinating the world. So we are at a stage where in Africa we have less than 2% people vaccinated. And we keep on saying this buzzword that no country is safe till the whole world is safe. But, and we all say we're facing the same storm, but in fact, yes, we are facing the same storm, but in different boats. Some boats are very strong and they will survive, but other boats have already started foundering. So when there is an occasion to use science and technology to improve life on Earth, yes, to explore space and to push the frontier, which we're doing, hoping to go to other planets, hopefully not to destroy them like we are busy destroying our planet. So I was very happy to support it. We are a small country. Our funds, when it comes to development funds, are tiny. But even those tiny resources, in fact, the more tiny they are, the more you have to spend them well, I think. And this is money very well spent. And I really look forward to to support this and to move on this. I mean, I hope it's just the first step. And there's a lot to do in this area.
Professor Borg mentioned to me during the preparation of today something to do with space diplomacy. He told me that this is something that the world is working on. I had never heard it before, and I would like to perhaps ask you to give us your take.
And I can tell you from my own experience that when I have visited a lot of countries since we spoke about and since we started supporting this project, thankfully, I find ministers interested that even when we discuss foreign affairs, we should be discussing these needs that have to do with health, that have to do with education, that have to do with, creating jobs, creating wealth. Because I think diplomacy should be, first of all, should be about as much as possible not, preventing wars and preventing conflicts. And unfortunately, I don't want to sound very pessimistic, but I want to be realistic as well. Unfortunately, it's as if the ministers of defense are more important than the ministers of foreign affairs, because we were pushing more what to do about, arming ourselves not in Malta, because Malta is considered a dysfunctional state, because thankfully we do not have a budget to spend on arms. But it's considered, according to those who think that hard power is very important, we're considered a dysfunctional state. I'm quite happy about that. So when you actually then discuss how space, how science can be used in our relations with each other, there are a number of countries, Joseph can tell you, I've put him in touch with a number of research organizations in other countries, and they are very excited because they share the same problems. If we're talking about diabetes, if we're talking about thalassemia, and how to address these problems, at least it will be something in the right direction.
Thank you very much. We, at the same time, are showing our audience. I think there was an in-screen, on-screen, yes, screen at one point. That is live from Florida, where we will be joining very shortly to actually see the launch of SpaceX. In the meantime, we have some more guests for you to hear out. And we have with us Professor Kevin Cassar online. He is the consultant vascular surgeon based at our National Hospital. Professor Cassar, can you
hear me?
Hi, yes, we can. How are you?
I'm fine, thank you very much. It's a pleasure to join you, and it's an honor to be part of this project.
Thank you very, very much. Thank you. Professor Cassar, you see hundreds of patients, many of whom suffer from type 2 diabetes. A number of them even develop foot ulcers, and this obviously leads, unfortunately, to amputation. But I'd like you to contribute to today's subjects and the importance of what is actually happening today.
That's right. So Malta really is going through an epidemic. The epidemic that we have is not COVID. Of course, we have COVID as well, which thankfully is well under control here. But our biggest epidemic is diabetic foot. And the diabetic foot problem, of course, for us is something that we see on a day-to-day basis. And unfortunately, Malta has one of the highest prevalences of diabetes in Europe. And according to the International Diabetes Federation, our prevalence is 13.9%. That is the highest in the whole of Western Europe. So compared to some other countries like Germany or others where the prevalence is less than 6%. So we have a huge problem to deal with here, probably more than most of our European colleagues. And the number of diabetic foot ulcers in Malta is absolutely staggering. Many patients with foot ulcers end up losing their toes, lose part of their feet, sometimes lose their legs. And when they do lose their legs, sadly, they often end up losing their lives. So while we're talking about space and this exciting project, we need to think that the potential benefits of these efforts are going to be on real patients' lives. So the number of minor amputations in our country has been rising and rising to the extent that over the last few years, we're doing over 400 minor amputations per year. And that is a huge number. When we compare our numbers to, say, Scotland, our minor amputation rate is over 25 times higher than Scotland. Now, some of that, of course, is because our prevalence of diabetes is higher. But even when we do correct for our differences in prevalence, our minor amputation rate is more than 10 times higher than that of some of our European colleagues. So we do have a big problem locally, which explains our interest and the need for engaging in such projects to ensure that, of course, we do our best to try and track this for our population. Why does it matter? Well, foot ulcers cause huge suffering in our patients, and we see this directly in the patients we meet on a day basis. Currently in Malta, we have over 3,500 people who've lost part of their foot or their toes, and more who have lost their limbs. So this is a big problem for us. Ulcers and gangrene in diabetes is one of the most common causes of hospital admission. So that is costly even to the nation, but more important, costly to the patients themselves who are going through these experiences. They need sometimes long hospital stays, they need antibiotic treatment, sometimes long antibiotic treatment, which we even continue in the patient's homes with a home antibiotic team that goes out to the patients at home to administer those antibiotics. They often need regular visits to the theater where we debride and clean these wounds and ulcers, and sometimes obviously carry out amputation. And in terms of the patients, this translates into huge losses, loss of mobility, loss of independence, institutionalization, and time lost of work. Remember that this doesn't affect only elderly patients, it affects younger patients as well. And this means that even for our country, it means also loss of production and loss of income, and also loss of the potential value of these people in the community and in society in general. Major amputations, unfortunately, as we said, are associated with high mortality. So if you're going to undergo a major amputation above the knee, 70% of those patients would be dead within 6 months. So when we talk about diabetic feet, we're not just talking about small grazes or ulcers, we're talking about life and death situations, which is why this is so important for us. So when we look about how we advance and how we progress and how we improve the situation for our populations, particularly in our country, we have to ask ourselves, what can we do? And the answer is we can do a lot. Projects like these are a step forward in trying to address these issues and also trying to improve the way that we deal with them and the way we treat patients and ensuring that we have better outcomes. But we also need other things. So in Malta, for example, although we have a very high prevalence of diabetes, we still lack a diabetic register. In other words, we still don't know who is diabetic and who isn't. That is, of course, essential, because if we know who is diabetic, we can target those patients. Once we know who is diabetic and who isn't, we can set up a proper national food screening program, which unfortunately we still lack. So there are a lot of things that we can do, not only in space, but even down here on Earth, and particularly in our country, to improve the lot of these patients. So my message really is that we need to continue to work on these exciting projects. We need to continue to advance our knowledge. We need to continue to advance our tools for treating these patients and improving their outcomes. But we also need to think about more mundane things, such as having a diabetic register, such as having a national food screening program, such as having a proper service to provide patients with adequate footwear to prevent this happening, rather than having to wait for months on end. So these are things that we can work on, and we are working on, and hopefully we will start to see investment not only in space projects, but also more investment in ensuring that our population, which has this very high prevalence of diabetes, improves the quality of service that it gets, and our very high minor amputation rates, this huge number of people losing their limbs, losing their toes, will be cut down at least to the levels that we see in other European countries. And finally, of course, it's a big pleasure and an honor to be part of this exciting project. And it is with a sense of pride that we can contribute and join Professor Borg and his team. And I've also finally want to thank our patients who have kindly accepted to be part of this project themselves. And it is part of them that is being sent into space. So the tissues that we're sending into space and the organisms on them are coming from patients who have kindly accepted to take part in this. And I would like to take this opportunity to thank them for their collaboration, to thank them for their willingness to contribute to ensuring that our knowledge improves. And while they might not benefit themselves from this, people coming after them certainly will. Thank you all, and well done, Professor Borg, and all the rest of the collaborators. Thank you.
Thank you very much, Professor Cassar, for the insight you gave us, and obviously for the passion and the work that you do with these patients. In the meantime, we are going to connect with Arkafort's mission control, actually, and we have some colleagues we're going to speak to shortly. But in the meantime, we'd like to explain what was happening here, as we were seeing that, unfortunately, the launch will not be happening now. These are, we were expecting things like this because this is what happens.
Yes.
Can you explain to us?
So, indeed, these type of launches, rocket launches into orbit and into space, highly depend on weather conditions, and that everything is up to spec and 100% sure that the mission will be a success. If there is the weather, which is not kind enough to allow a successful rocket launch, then generally they use the word scrubbed for a next day. So it seems
Just
that,
now?
that just now in maybe it could be. So actually, it would be interesting to connect what's happening with Florida.
They have
because
just
there
started
are two things which can happen.
Okay.
One is that they will delay on site by a number of minutes, and they say we shall wait to see whether the weather actually subsides, and therefore the launch can progress.
Okay.
Or else, if the launch will not happen, therefore it will be scrubbed to a next or later day.
We are online. We are checking as well as we speak, so we will keep you updated. Nonetheless, of course, at the moment, the importance of this time we are doing here online during this webinar is to put you in the picture of this important event for us Maltese of Project Maleth leaving into space, whether it is now or whether it is going to be in an hour or tomorrow, it is still going.
Yes. So in that case, for the benefit of all the public who are viewing this webinar and this discussion, of course, for people who are knowledgeable about these launches, I need not tell them where to look for these launches. However, for the general public, we shall be making available the direct link of the launch on our social media, be it Arkafort. We shall also discuss with the University of Malta and also with TVM. So the exact link or the streaming of the launch will take place. Will be given.
Fantastic. Thank you very much. We will now be connecting with Justin Fenech, who is the co-founder and executive director at Arkafort, and Glenn Shortino, as well at Arkafort. They are both in the mission control. I'm curious to see what this mission control looks like, so I hope that both of you can show us around. Justin and Glenn, can you hear me?
Yes. Can you hear us?
Yes, we can. Hi, how are you?
Hi, thanks for the intro, Claire. We're all set up here. Unfortunately, we just been notified that the launch has been scrubbed. Well, we are here in the mission control room, which is an extension of Arkafort's 24/7 help desk. Well, over the past week, we've been working to set up all the equipment so that in a few days' time, we connect to the space station. Well, we are very privileged to be the first company based in Malta to establish a direct communication with the space station. Well, I will leave it to my colleague Glenn to explain in more detail what will be happening over here.
And in your hands.
Good morning to all. About 2 weeks ago, I had the opportunity to visit Space Applications Center in Belgium together with Prof. Borg, where we were the last two people to actually see the cube before it was assembled and sent to Florida. And while we were there, they gave us the necessary tools for us to be able to connect to the International Space Station once the experiment is on board, for us to be able to control conditions within the cube and enable the researchers to observe the samples that were included in the cube itself. Just to give you, I don't want to go into a lot of details, but I can give you a bit of sneak peek of the mission control application, which will enable us to view telemetry data, basically data about the cube's condition, temperature, acceleration, and that sort of stuff, and also be able to control lighting conditions, take pictures of the samples themselves, stream live videos as well from the cube. Obviously, at this point in time, it's not connected to anything, but once the launch actually occurs and it is connected, which is, I believe it's scheduled to be online for the 2nd of September, if all goes well. So I'll be sharing my screen. Just one moment. Can you see the screen?
Yes.
Okay. I'm not sure whether you can see the space on my screen.
Yes, we can as well.
Okay, so basically from here, we'll be able to see some information, for example, ambient temperature within the cube. Obviously, if we start turning on the lights and water and the other things within the cube, the temperature might rise a bit, but it's usually very stable around 21 degrees Celsius. We're able to receive the packets and making sure that the connection is stable as well. There's basically 3 sets of lights within the cube. So there's a backlight behind the cubes, the cuvettes where the skin samples are. So we're able to illuminate the cuvettes from the behind. We have also lights underneath the individual cuvettes, which we are able to control from this part over here. So we have 6 LEDs for each of the 6 cuvettes. And we also have an RGB lighting that's at a 45-degree angle pointed to the roof of the cube, which will enable us to give some soft lighting to take better pictures of the sensors themselves. We basically have 2 cameras on board the cube, and we have one which will give us a view of the whole samples of the 6 samples, and one which is directed to the last 2 cuvettes, so cuvette 5 and cuvette 6. These are very, very high resolution cameras, will be enabling us to take very, very good pictures, which will hopefully obviously show the public during the course of the experiment. And also we'll be taking several pictures along the 40 to 50 days of the experiment, which will then be able to compile into a video, a time lapse of the whole experiment. And that's basically it. So from here at Mission Control, we'll be able to connect directly to the private network that the ISS forms part of, and we'll be able to do all this stuff as well. So we'll be able also to stream live video from the International Space Station and from within the cube, and that will obviously, during the course of the experiment, will be diverging more information and maybe links to the streams and so on.
Thank you. Thank you. We just have heard about the time at the moment that it is estimated to leave.
Yes, so it appears that the launch will take place tomorrow, but at the same time that we were expecting today, meaning at 9:30 or 9:37 local time in Malta. And this will be shown live on NASA/SpaceX TV channels, which we will be posting the links online on our respective social media.
Very good.
It is what it is.
Yeah.
Unfortunately, rocket launches are a little bit more complex than flights by airplanes, and we have to abide to these rules.
Of course, but we're all set up, and so do our colleagues Justin and Glenn from Arkafort Mission Control. They seem everything's working, everything's set up. So at the moment, I'd like as well, first of all, to thank you for giving us this brief and showing us around the mission control, and also mention a little bit about, because he said we can see the video.
Yes.
Let's see what was sent as well in this ice cube, because this is something interesting and also a very good initiative that you created for educational purposes.
Yes. So essentially, in this cube, besides the pure scientific experiment, which from here I thank Professor Kevin Cassar for his excellent representation of the material, the biological material, and the patients themselves, and the problem that we are tackling, which is diabetes and diabetic foot ulcers. Now, in the context of having this experiment, this cube, which contains its own mini hard disk or SD card, okay? So we had come up with the idea that essentially anyone, and we thought primarily of our young kids and school children and other entities and NGOs, to have their ideas written on paper as a message, as an artwork, as a drawing, even video clips or a recital of a poem. And these can be essentially embedded in a digital manner into the cube. They will find themselves up into the space station, and through the control center based in Ormi, we are able to stream and show these files and art and painting and crafts that our young children and Maltese youngsters did for this experiment. and we will be able to stream it from space to Earth, to Malta, and elsewhere.
And they had no problem understanding this concept,
Not at
I
all.
think.
Not at all. So actually, when we did suggest this idea, it is impressive and amazing how the children sort of subscribed to the idea.
And now their messages will be in space,
yes.
and they can log in and
yes.
play the song. In fact, there was a very beautiful video
yes.
which was done, which can be accessed as well and seen, and other
yes.
messages.
There's a very interesting video by San Andrea School, Sing for the Climate. This is also interesting. It's not something which we don't know, but what Earth is facing in this time and point in the environment and the climate change. So it's a very apt moment for this video to be aired. And we also have a big participation by St. Michael's School in Pembroke, and a large number of schools from all over Malta. So the public will get to see these contributions as we progress during the month of September. We will be doing, like a small program of events digitally, so the people can view these contributions.
We will be concluding shortly, and in fact, I will move on and conclude with the Minister of Foreign and European Affairs, even to link this education. But first, she's been here with us all the time, and I've been wanting to find the time to speak to you. I need to speak to Christine. Christine Borg is the person who initiated, in a way, this study. And quickly, I would like to ask you some questions. First of all, how are you feeling today after having heard all this?
Yes, excited, motivated, and looking forward to see the results of this experiment. So, yes, very excited.
You are a PhD student still. What was it like to do this study? And also, can you tell us a little bit about the microbiome?
Okay. So, as we have already heard from Professor Cassar as well, we have diabetes is very, very common in Malta. We have a lot of people suffering from this disease, around 60,000 people. Therefore, also, as he said, we rank very high in our other European countries. So what happens in these patients is that they have ischemia, which is low circulations in their feet, as well as they suffer from neuropathy, that is numbness in their feet. Therefore, they are prone to form these ulcers. These are very difficult to treat, and they heal very slowly. Also, as Professor Cassar said, we do not have the national diabetic foot screening program. Therefore, these patients are not monitored in order to prevent these ulcers. Therefore, they tend to present very late in hospital. And the only cure would be amputation. And we also have a high rate for 100 amputations per year. That is more than 1 amputation per day in Malta. So in this study, in this research, we are going to look deeper into these ulcers and see all the bacteria that are causing these infections. So what we are going to do is Professor Cassar and all his doctors will collect surgically some tissues from these diabetic foot ulcers. They are going to be sent in our laboratories, where I would be cutting them up into smaller pieces to be better analyzed. We are going to analyze them by culture, which is the current method, which is used in our laboratories, as well as analyzing them using molecular technologies, next generation sequencing, so that we can better identify all the bacteria that is present, the microbiome which is present in these ulcers. So the microbiome on our skin, as well as in our other parts of our body, we have a lot of bacteria which we are living together harmoniously. And they are very, very important, and they have an impact on our health. Now, when the skin is open or broken, like in an ulcer, these skin microbiome, these bacteria, would enter into this wound. And together with other pathogenic bacteria that would be present in the environment, they would cause very nasty infections, and ultimately they would lead to amputations. So apart from that, we are also going to take skin swabs from these patients in order to collect the skin microbiome. And we are going to compare both the microbiome on the skin as well as in the ulcers, to see if there are any similarities, differences, if there is any shift, if there is any bacterial species which can be a predictor of prognosis, if that ulcer is going to respond well to treatment or not. And we are also going to look in different biomarkers, since our human body is one whole system, it is all integrated, and biomarkers that are traveling and circulating inside our body. And together we will have a broader picture of what is actually happening in these patients.
How will the patients benefit from this research?
Yes.
Of course, like Professor Cassar said, it may not be them themselves, but certainly.
Exactly. So 70% of all the medical decisions with regards to patient treatment and diagnosis is done from laboratory results. I would like to thank all the biomedical scientists who are working tirelessly day in, day out in our labs to provide accurate and timely results and reliable results to our doctors. So medical research is always important to improve the quality of life of patients. However, we cannot focus only on the human body. We also need to focus on the microbiome, which is actually living on and in our body, because that has a high impact on our health. So we are going to look into the genome of this microbiome, and with the knowledge that we already know locally, as well as the knowledge that we are going to accumulate during this research, we will better understand how the ulcers and microbiome behave, and ultimately better treat and manage these ulcers, so that the quality of life of these patients would hopefully improve.
Thank you very much. I would like to pass on to you, Honourable Minister, to close off today's event. Obviously, with what you've heard, your message.
It's just a message which I will borrow from the words of Viktor Frankl. Viktor Frankl is a Jew who was in the Auschwitz concentration camp. He managed to survive. He managed to survive because his philosophy was, those of you who have watched the film La Vita è Bella, is that even in the most darkest moment, you have, some sparkling light. And he tells us, and what I find amazing is that he didn't come out of the experience full of hate, or full of revenge, or full of bitterness, or full of self-righteousness. But very humbly, he tells us, the world is in a bad state, but things will become worse if we do not do our best. And I think this is what we're doing here is something to at least, if not improve the world, not to make it worse.
Thank you very, very much. We're ready to bid you a good morning and a very good rest of the day from here to you online who followed us. As we mentioned, all the social media platforms supporting us, thank you very much. There was TVM, there was Arkafort, and also the University of Malta, that's right, thank you very much. And I have spaceomics.com as a website for you to follow, to continue following the project. And I think besides that, we'll bid the mission a very good luck from us all.
Yes.
Let's hope that tomorrow, the people who are going to see it, we see it take off. If not, we will continue following. Like we said, I'm sure it will be taking off. And sending your science program, the first multi-science program to space.
Thank you very much.
Thank you
Claire.
all.
Thank you.
Have a lovely day.